All right, so our new unit is still in quadratics, but we're looking at quadratics in factored form. Our previous unit, we looked at quadratics in vertex form. We were able to find the vertex. We were able to graph using step pattern from the vertex. We talked about optimal value, maximum, minimum, direction, opening, all of this. Now, vertex form was very useful because I was able to find my vertex. I was able to find my optimal point. But sometimes it's not in vertex form, or sometimes I don't know what the vertex form is. And the other form is called the factored form. The factored form, let's just recap. The vertex form looked like where you had y equal a, bracket x minus h squared plus k. So this was the vertex form. Okay? In this unit, we're going to look more in detail about the factored form, which look like this. That's factored, y equal a, and then we're going to see the a value, still the same thing, but we're going to see also two brackets that are multiplied together. Okay? We'll talk more about this once we get to it, but this is basically what we're going to discover in this unit. We're going to learn how to go from vertex to standard. We're going to learn how to go from factor to standard and from standard to factor. Okay? Remember that the standard form for quadratic look like this, where it's expanded. Okay? This is called the standard form or expanded. Expanded. Okay? So we're going to learn how to go from one to the other. Okay? If I have standard, how can I go to factor? If I have factored, how can I go to standard? If I have vertex, how can I go to standard? Okay? Our first lesson of this unit is learning how to go from factored to standard. Okay? How can I expand? We did some of it in the review. Okay? When we did the review, do you remember the distributive property and FOIL? Do you remember this FOIL? FOIL, and then we talked about the first, outer, inner, last. So basically, that's what we're going to talk about today. Okay? But I'm going to show you different methods. In the class, when I'm working on the board, I'm going to use the FOIL method, which is one of all of these methods. Okay? It's just I'm going to show you the different ones just in case you prefer one other method. The first one, which I usually show a YouTube video, but the YouTube video is no longer available, it's called the algebra tile area model. Okay? Which means you're using manipulatives. We don't have these manipulatives in this school, but some high schools, I don't know if you have any, probably none of you have any kids in the high school right now, but there's some high schools that have these manipulatives. Maybe when you were in high school, you've seen them, where you have like red squares and green squares. In elementary school?
Yeah.
Okay.
They have them in elementary.
And
That's
then-
how they teach math.
And then you can use these special tiles in high school as well to multiply. They take longer time, right? It's not the most convenient. It's just for people who can't do math on paper. This is a good way for them to visualize it, to see. Okay? And then what that says is, for example, if I have x plus 4 times 2x plus 1, okay? So I'm multiplying these two, all right? I want to expand and I want to simplify. So what they say is anything that says x, you're going to show them as long rectangle. Just the unit, so the ones, you show them as a small square, and the x square, you show them as a big cube, as a big square. Okay? So if I'm going to multiply these two, you're going to set up a table, and then you're going to have x plus 4. So you have one long one, and then you have 4 small ones. Right? This is what I have. X, I have 4. All right? Then for this one, you have 2x plus 1. What should I have for the top one? two long ones, and one small, right? Then you're gonna multiply, because remember that we're multiplying, right? So when I multiply, I'm gonna multiply an x by an x. So if you're multiplying two rectangles, what are you gonna end up with? One big square, which is x squared, right? Because remember, this is x, x, x. This is 1, 1, 1, 1, 1. Again, you're going to multiply this by the other x, so you're going to end up with x squared. And then when you multiply x by 1, what are you going to get? X. Okay? Then you're going to keep going, and then you're going to multiply 1 by x, right? Which is going to give you x. 1 by x. 1 by 1. 1. This is going to be exactly the same thing because I'm multiplying that 1 by the same thing. So I'm going to have 4 of this. You see how long that takes? Right? And now my final answer is going to be to add like terms, right? So if I'm adding like terms, I have x squared and x squared. So how many x squared do I have? 2 of them. How many x's do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So that's going to give me 9x. And then I have 1, 2, 3, 4 ones. So that's plus 4. And that will be my final answer.
That's it?
That's it.
Who came up with this idea?
I don't know, not me.
We have to do this?
No. But this is for the people who better visualize things. Okay? You want to do it, you can do it on a piece of paper if you want. Like, you don't have to show it to me. But if you find this method easy for you, go ahead and do it. Okay? It will take you a little longer, but it's still doable. Okay? That's one way to do it. Now, you have to be careful when it comes to negatives, right? Negatives and positive, they cancel each other. Okay? So I'm going to just create another example here with a negative. So let's say if I have x minus 1 times 2x plus 3. Okay? This is an example with a negative in it. So when I do this, again, anything that's not highlighted, that's not colored, that's going to be the positive. To represent the negative, we're going to represent them with colored one. So if I'm looking at negative x, we're going to color it, and then we're going to say this is negative x. Sorry, negative x. Okay? The x squared, it's going to be colored negative x squared. Okay? The 1 or the negative one. Or you can use different colors if you want. If you have different colors pens, you can use different colors. Okay? So, for this one I have one long one, which is x, and then minus 1, so that's going to be a square, but it's going to be colored, and that's going to be the minus 1. Okay? For this one I have 2 long ones and 3 small ones. Okay? Now, if I multiply x by x, what do I get?
X squared.
X squared. So that's my square. Right? X with an x, again, it's going to be x squared. X with 1, that's going to be x. And there's 3 of them. Right? X, x, x. Are we okay with that? Now here's where the negative is going to play in. So I have negative 1 times x. What is that going to give me?
Negative x.
Negative x. So that's going to be a colored one. Same with a negative 1 times the x. That's going to be negative x. Again, it's going to be colored. And then negative 1 times 1, that's going to be negative 1, negative 1, and again, negative 1. Okay? So when you come to add things, you're going to have to be careful like terms first. So what are my like terms? How many x squared do I have? So that's going to be 2x squared, right? Then I have 1, 2, 3x, but then I have 2 negative x. So what's going to happen is the positive is going to cancel a negative. A positive is going to cancel a negative, so I'm going to end up with 1x, right? So plus 1x or plus x. And then I have 1, 2, 3, that's negative 3. Okay, so I ended up with this. All right, so these are this is what we call this is what we call the algebra tile method. Okay, again, you use it if you really struggle with the algebra and just multiplication. We can use also the algebra tile method, but with numbers. Okay, which is same idea. Okay, so you can draw a table. Okay, and then you're multiplying x plus 4 times 2x plus 1. Okay, so you're gonna put the x plus 4 on the vertical line or on the column, and then you're gonna put the 2x plus 1 on the row. And then you can do exactly the same thing as we were doing with the algebra tiles. So you're going to multiply. So x times 2x gives me 2x squared. Remember, I'm multiplying. X times 1, 4 times 2x, 8x. Remember, I'm multiplying. 4 times 1, 4. So remember here, there is a multiplication. Okay, so now again, looking at this, I'm going to collect like terms, right? So collecting like terms for this, I'm going to end up with 2x squared because there's no other x squared. I can collect these like terms, which is 8x plus 1x, which gives me 9x plus 4. Right? Look at this. If I did it with the algebra tile method, or if I did it with the chart method, I got the same answer. Okay? Then we have the expand and distributive using the distributive property. This is probably one of the most complicated of all of them because it's kind of like forcing you to write x times, so you're going to do the x times the 2x plus 1, and then plus 4 times the 2x plus 1, right? So you're going to do this times this whole thing, and then you're going to do this times this whole thing. Okay? It's easier. FOIL is the easiest one of them. Both of them are easy. So now you're going to use the distributive property. For example that I've given a long time ago, right? Distributive property, that means you're multiplying whatever's outside with whatever is inside the bracket. So I have to multiply x times 2x, which gives me 2x squared, x times 1 plus x. So I'm done with the first bracket. Now I'm going to move to the second bracket, and I'm going to multiply 4 by 2x, 8x, and then 4 times 1, which is 4. Something that a lot of people mistake, or the mistake that a lot of people do, is when they are multiplying, they forget that they're multiplying and they actually add. That's not correct. You make sure that you're multiplying. Okay, now if I'm going to collect like terms, I don't have any x squared, so that's going to be 2x squared. X plus 8x, that's 9x. and then plus 4. Again, I'm getting exactly the same answer, no matter what the method I'm doing. And you have to remember that at the end, you are collecting like terms. You're simplifying. Not only you're expanding, but you're also simplifying. Are we okay with this? Which brought us to the FOIL method. We've talked about the FOIL method before, and we said that we're going to multiply each term in the first bracket with the term inside the bracket using the FOIL method, which represents first, outer, inner, last. So that means I'm going to multiply the x by the 2x. That's my first term. So that's 2x squared. Then I can multiply my outer term. So that's x times 1, which is x. Then I'm going to multiply the inner terms, which gives you plus 8x. And then you're going to multiply the last term, which is 4. And that would give you the same thing, 2x squared plus 9x plus 4. Okay? Remember, 2 arrows have to come out of each term from the first term. All right. Okay, so you're gonna practice expanding. All right, the next, the 4. Before we get to, I'll get you guys to do that, and then we'll check out the answer. Can you guys tell me what does it mean when you're writing 6x plus 1 squared?
You're gonna say 6x plus 1 and then 6x minus 1.
Nope.
It's the same.
It's the same, right? Because that's twice. So that's 6x plus 1 times 6x plus 1. Okay? So you write it twice so you can do your FOIL method. Okay?
FOIL, do you multiply or?
FOIL, you multiply.
Okay.
The only time you add is when you're collecting like term at the end.
Okay.
Okay? But otherwise you are multiplying your terms. Okay? Can any of you guys who work on this, you can work with another person if you like, or check your work with another person.